welcome to the ArcGIS for Maps SDK for Flutter Advanced Workflow session. My name is Paul Sturm, and this is Martino Yovo. We are on the ArcGIS Maps SDK for Flutter team. And before we get rolling, I just want to do a quick survey. So who here was at the Building Apps session just an hour ago? And how many of you managed to get all the way to the lunch and back in the last hour? I brought a sandwich. I was not going to make it. That isn't in my notes. Okay. Oh, where am I? All right. So who here is already shipping a Flutter app? Is there anyone? Then are you using the Maps SDK in your Flutter app already? And with real customers, they're using it? Nice. That's what I like to hear. It means we're doing our job right. All right. So, and then just one note after the session, please remember to share your feedback in the Esri Events app. It should be on your mobile phone, under My Event, My Surveys. And right with that, let's begin. So here is our agenda for today. First, we'll talk about some things to watch out for as you grow your Flutter app and how to handle them. Then we'll see some of these techniques in action with a pair of demos. And then after that, we'll have time to take your questions and then offer up some next steps. So my basic thesis for you today is that as you grow your Flutter app, you will face ever-increasing complexity, and to manage this, you'll need to apply patterns that keep the complexity in check. And we'll introduce some of those techniques today. So let's say that this complexity builds in 3 dimensions. We'll call them X and Y and Z. So X will be the dimension of your widget hierarchy. And then along the Y-axis, that will be the layers in your application architecture. And then we'll use Z to represent your graph of software component dependencies. I was going to use latitude, longitude, and altitude, but that involves too much trigonometry. So we're just going to do X, Y, and Z. No. Okay. So starting with the X dimension, you will find that building a Flutter app quickly involves long and deeply indented build methods. And the build method is the basic widget callback that creates your widget tree. Kind of the centerpiece of a Flutter application. And so what happens is maybe things start out okay with a simple stateless widget. Then you find you need to keep information in some state variables, and you refactor it into a stateful widget. And then you add rows and columns and stacks and padding widgets and all the other necessary things. And that's when you end up with a gigantic build method. And Flutter seems to encourage this because widgets are intentionally designed to be narrowly focused and always need to be composed with other widgets to accomplish any non-trivial task. So to fight back against this, you need to reclaim simplicity as you go. This starts by using your IDE's refactoring tools to split off branches of your widget tree into separate widgets. Your IDE tooling is truly invaluable here because it's really a chore to do manually. And there's something of an art deciding where to split out separate widgets. And here are some things to look for. Look for clusters of state variables that closely interact and generally change together. If they can be isolated and cordoned off into a separate widget, that'll be a win. Look for collections that are presented in list widgets. An individual record in the list will usually make sense as its own widget. Also, many widgets have a builder callback where you return your custom widget to the container widget. The widget you build there will likely make sense on its own. And then lastly, any subset of your widget tree that can be turned into a stateless widget is a good candidate. because stateless widgets are uncomplicated and easy to reason about. Breaking down your widgets this way will help you keep your UI manageable. And then my third tip on reclaiming simplicity is to make use of Flutter's pre-built widgets that manage state changes for you. Flutter provides widgets such as Future Builder, StreamBuilder, and Value Listenable Builder. And these widgets abstract away the logic necessary to manage the events from, respectively, a future, a stream, or a value listenable. Your code's responsibility is simply to respond to the state provided by the builder method and produce the corresponding widget tree. You are relieved of having to track events and drive rebuilds in your own code. By performing this refactoring work as you go, you can keep your code understandable and maintainable. And then here are some additional tips as you design and build your own widgets. First, take lessons from the built-in widgets like StreamBuilder. Design your own widgets to have a focused purpose and with composability in mind. Separate out state management from rendering the user interface and use your own builder callbacks to provide customization points. And then on the previous slide, we talked about factoring out sub-widgets. And in addition to managing complexity, this has an additional benefit in that it usually helps you optimize the performance of your UI. When Flutter is rendering your UI to put it on screen, it has only 16 milliseconds to prepare each frame. So slow rebuilds will eat into that time and will lead to janky UI performance. To avoid this, you want to only rebuild the parts of your widget tree that actually do need to change. And so with properly chosen widget boundaries that limit the scope of state changes, your interface can remain silky smooth. Lastly, and this one's maybe a little controversial, if you find yourself reaching for an empty set state call that looks like this with an empty callback, I can almost guarantee that you got off track somewhere earlier in your process. An empty set state like this will force a rebuild of the entire widget, and that makes it an attractive solution when certain changes aren't being reflected in the interface. It's easy enough to just call set state and rebuild and sync everything back up. But it also means that somewhere along the way, you lost track of which state changes should drive which changes in your widget tree. Resorting to an empty set state means that you can no longer reason about the relationships between your application state and your widget tree, which will inevitably snowball into bigger and bigger problems. So that's sort of a code smell that I notice. It's easy to reach for, but it probably means you're digging a hole even deeper. All right, so if your widget hierarchy is stretched out along the X dimension, let's call the Y dimension your app's layered architecture. It's a common progression to start with a massive stateful widget that combines your application state, business logic, data access, and user interface code all in one. It quickly becomes prudent to restructure your code by separating out the user interface from the logic, and then from there separating out the data access layer, where the data access layer manages communication with your server APIs or on-disk data. So to manage complexity here, the recommendation is to adopt a formal architecture that creates separate layers for each of your user interface, business logic, and data access. And then there are many different packages and tools in the Flutter ecosystem to help with this. They all have their own terminology and approach, and they all disagree with each other. But ultimately, the value comes from having a proper separation of concerns and applying a pattern consistently. And then a couple of Flutter packages that are worth investigating are Riverpod and Block, where Block is spelled B-L-O-C. And then at this URL, there's a good discussion of all of this, of talking about layered architecture on Flutter's website. So docs.flutter.com, And then you can either find it in the table of contents on the left, or you can go straight to app architecture concepts. It covers this topic at great depth, both at a conceptual level and with an example application. And then finally, let's call the Z dimension the web of dependencies that grows within your software components. This might be objects in one layer depending on objects in the layer below, or it could be objects dependent on other objects in the same layer. And so the recommendation here is to adopt a dependency injection pattern. And the basic principle there is that you turn your objects inside out. Instead of having an object create its own dependencies, you instead expect those dependencies to be passed in to your object, such as through parameters to the constructor. And that provides you the flexibility to more thoughtfully manage your dependencies. And usually that's combined with defining an abstract interface that specifies the contract between the objects without getting tied to a specific implementation. And that provides another level of flexibility. And then so because of that flexibility, it brings its own complexity, which has to be managed. When the responsibility to create a dependency has been moved outside of an object, that responsibility will have to be taken up by some kind of provider object, something that provides an object with its dependencies. The provider has to manage the lifecycle of all the dependencies, which is when those objects are created and when they're destroyed. And it also has to manage the subdependencies and the whole graph of dependencies that might stretch below. And you'll likely want to adopt an existing package to manage this, such as the one called provider. That's how you know it's a provider package, because it's called a provider. And then, or there's another one called riverpod, which if you look at it closely is just an anagram for provider. That's where they got that from. And then perhaps the biggest side benefit that flows from adopting this pattern is that it greatly increases the testability of your code. So one common hurdle to testing any individual class is that it might require you to spin up a large portion of your running app. But if all an object's dependencies can be provided to it, and if they each have an abstract interface, you can provide an alternate implementation for those dependencies. You can use mock objects tailored to the particular testing scenario, and you can avoid having to interact with services over the network or deal with data on disk. This is simpler and usually faster both when running the tests and when implementing the class. So now let's see some of these concepts in action with a pair of demos. For the first demo, Martino will show us how to connect a StreamBuilder widget to an ArcGIS data source. So let's jump over to his machine.
Yep.
Did we jump yet? No, this one. We have jumped.
Yep. Thanks, Paul. All right, so let's build some cool stuff. Yep. So my first demo, I'm going to share and show, I'd say, a very simple but practical reality pattern with our Flutter Maps SDK. So in this demo, we are going to build a 3D scene for a development project area. And the idea is to allow us to kind of see like the project boundary, the contextual layers like trees and also the buildings. We are going to kind of connect the layer that directly to the UI. So let's get started. Yep. So right now I have, the ArcGIS scene view that you can see. And I'm going to show you basically how this is going to go. So I defined initially a factory. And the goal of this factory is to allow us to have all the scene data we need in one place so we can work on this project. So it is returning the group layers scene data, which is an object that I defined, and is actually returning three things. So the first one is the scene. The second one is the group layer, and the third one is the project area layer. Now, let's see a bit what the factory consists of. So initially, what I did was that I defined a group layer, which is here, and I give it a name. And I also define the project area. And this is coming from a feature service. That's why I use the service feature table here. And I'm creating a feature layer out of it, and I also named it. And I had also created two scene layers. So the first one is for the tree. They're coming from service URIs. And I also have the building layers as well. And I'm adding all these layers to the group layer that I initially defined here. And after that, I am defining or creating like a scene. And this is basically using the imagery base map. And I'm adding the group layer that I defined to the operational layers of the scene and returning the group layer scene data object. So yeah, now let's go over and see this working. So I'm going to bring over my simulator, and here right now, let's say I restarted it. So yeah, now when it opens initially, it just show the scene. So the next thing I'm going to do is to load the project area, and the goal of that is to be able to center the scene view on the project area. So let's go and do that. So have my widget here. So here, just so you know, I have my ArcGIS scene view widget here, and I'm going to load the project area when the scene view is ready. So I'm going over here and I'm loading this one. So after loading it, I want to, like I said, I want to center the scene view on the project area. So I will do that by using my scene view controller and then set the viewpoint camera directly to the project area extent. So I will do that by doing scene view controller, and yeah, it's done. So we got the full extent of the project area, and we are basically setting the viewpoint camera to it. So when I reload it, and I'll try to just go back. And now you can see we got the scene view centered on the project area. So initially, this is what we have. Yeah, now what I want to do is to be able to, I would say, toggle the visibility of the layers, right? So now it's just a block. But what if I wanted to just show the project area or show only the scene, the buildings, or just the trees? So when I kind of zoom in, you can see the trees here, okay? So yeah, let's do it. So I'm going to define a bottom sheet widget that will allow us to now do this customization, basically toggling the visibility of the different layers that we have. So right now I have the setting button. It's not doing actually anything. So I'm going over and adding the bottom sheet widget. So I have my scaffold here, yes, let's just do it right here. Okay, so I have my bottom sheet, and I can just have my visibility defined. So I can call like the bottom sheet setting. Let's see, the build. Yeah, and yeah, we go. And we also have a flag, just to check when the setting is visible. So I'm just gonna guard like the view. So I'll do. If setting visible, then give me the build setting bottom sheet, and otherwise just show me like a null widget. So now we have it now. So the next thing I'm going to do is to define, I would say, like create like a StreamBuilder widget, and I will explain that a little bit more. So here I have the layer visibility row. So this is what we're seeing right now with the clear button. Now, right below this, I'm going to define like the StreamBuilder widget. So I'll do the StreamBuilder widget. So I have it this way. Now, what this is going to do is that is going to allow us to toggle or like change the status of the visibility. So now here we are mainly focusing on one specific API, which is the group layer that on visibility change, right? And the idea behind the group layer on visibility change is that the visibility is not just one single, or one-time value. It changes based on user interaction with the UI. So that's why we are basically going to use the StreamBuilder widget here because it fits it, right? It's not just like a one-time completion. So when I call it this way, I have nothing. I just have the group layer name, which is showing here. So I'm going to now add like a widget to now allow us to toggle the visibility. Now, the best widget or like the ideal widget here would be a switch. So I'll add like a switch. Yep. So let's bring the switch. And the goal is to have like 1 second. Yeah. So we can now have like the value of the layer that we want to see. So here I'll just pass it on like this and do like group layer that on visibility change and show like 1 second. So I have the bottom sheet here, which is right. So I would do, bottom sheet, switch. I'm not getting the switch, so I'm not getting my switch. So, let me just show it this way. Now the value here, if I just want to go with this, I can define like the value. So I can say var is visible or something like that. And then I can just do the group layer. We have the group layer here. Yep. Let me just copy this. And
It would just be group layer dot is visible.
Yeah. We have
Let's delete the unvisibility change part.
Yeah. Okay. Yeah. So visible is visible here. So now we can now call the value here and then like act on this. Okay. So now we can basically just switch every single time. So we will do visible and change like the value like this. And then this will be like a V and we will basically just assign like the V to this one. And then one thing we can do is just kind of add in a spacer here. And this will allow us to, have the switch a little bit farther from the name. And I can wrap this in a padding just to give some spacing. So the ideal thing I would do here would be just kind of bring like a padding and define like, the edge. And add maybe a symmetric value, horizontal, and 12. And I will call my child widget, and I will just kind of wrap this in the padding widget. So now it's better, and we still have, we should do this. So we need to kind of check a little bit, the invisible. So, it's not really a problem.
Then you have to take group layer dot is visible equals.
So group layer dot visibility. like this. It's visible. And then we can set it like this. Now, every single time that I kind of toggle it, you will now see is basically just, showing and, kind of removing like the layers. So let me just go back and show you this better. So right now we have it like this. So that's the first aspect. Now the second thing I want to do, remember when we were defining like the group layer scene data, we have like the group layer that has multiple layers. So let's say we want to go over and also, kind of show or like, make them visible or sometimes no. So we will do that basically with a map. So it's like we are going to map all the layers in the group layers and then kind of, do basically show the switch widget as well so they can be customized. So, in order to do that, I'm just going to call like a group layer that map, and this will just allow me to just have, this sort of functionalities here. So, we have like all the layers mapped, and you see when I kind of enable the visibility of the project group area, now all these switches are also, visible or active. So I can just switch, and every single time that I switch, that specific layer got, switch, whether we show the visibility or not. And same for the trees, you can see it, changing. So that's like the first demo. I can also, again, wrap this in like a padding widget just to make it a little bit better. Same. So we have the edge insert here. And let's give it a symmetric. And have the, let's call the child widget. Yeah, I need to just kind of, Yep, and then child. Cool. Okay, so this basically is, what we want to show first. Now, there is one important thing that I would like to highlight here. So instead of just using a stream here, like we're using a stream builder here. So I'm going to try something. So instead of using a stream builder, I'm going to use a future builder. So first thing you will notice is that, the stream property is not defined here. So I got to change it to a future property. So if I do it this way, definitely it's not going to work because it's like we are kind of assigning, a stream to a future, which is not going to work. But one thing we can do is that we can ask Dart to just give us like the first, stream event that is emitted. So in that case, instead of just using the onVisibility change, I'm going to kind of get the first event here, and now my code can run. So when I do that, I just, reloaded the project, so I'm going to close this. Now, when I come back, look at what's going to happen. So here, when I kind of toggle it, like I switch it off, it shows like, no layers is shown, which is basically what we're doing. But I can no longer, you see here, I can no longer actually get the value when I'm enabling it. And the reason why it's basically working like this is because this is like the group layer that onVisibility changed is an ArcGIS event. It's not a future. It's not we cannot compare it. So in this case, when you are working with an event in our SDK, it's always better to use a stream instead of a stream builder instead of a future builder. So that's it. Thanks, and I'll pass it over to Paul.
Okay, yep. All right, so let's review What am I looking at? All right, so let's review some key takeaways from that demo. When working with the Maps SDK, you'll see many events modeled as a stream. And the basic way to work with a stream is to subscribe to it by calling listen, and then you cancel the subscription when you don't need it anymore. That's the usual work you have to do when working with a stream. But the StreamBuilder widget is the perfect match for listening to a stream. It's simple, readable, and reactive, and it manages the stream subscription for you. You simply respond to the callback and produce the widget that you want to represent the given input. So that takes some of the burden off of you to manually code that. And then there are several of these primitives with corresponding widgets. And then you choose the one that models the desired behavior. So a stream is for events that can fire multiple times. A future is for tasks that have a distinct beginning and end. And then a similar concept is the value notifier, which is for properties that can be modified and fire a signal to multiple receivers. And each of those types has a corresponding widget that synchronizes your UI with those events. So for a stream, you can use a StreamBuilder to manage that. For a future, you can use a future builder. And value notifier, you can use a value notifier builder. The names get kind of long, but hopefully that makes sense. And then in the second demo, Martino will implement some of the architecture patterns we talked about earlier, and we'll adopt a third-party package to assist. So let's switch back to Martino's computer.
Cool, thanks, Paul. So in this demo, we are going to do a refactor, not a rebuild. So the goal is to keep the StreamBuilder behavior and then improve it with Riverpod, MVVM, and basically dependency injection. But in our case, we are not going to use any other dependency injection. So if you are, in that ecosystem, you know that we have some dependency injection package like Get-It and others. So in our case, we are going to keep it simple due to the sake of the demo. So first thing I would like to showcase is basically the MVVM, architecture. So I sent for the model, view model, and view. So first is the model. So here you can see we have the view model, which the model which is defined here. So basically we have the ready flag, the setting visible, and also the group layer object as well. So that's the first thing. The second thing I will highlight is the view model. So in our case, the view model is actually allowing us to kind of keep it the user intent. So when we talk about user intent here, these are behaviors or action that user want to perform, user want to toggle visibility or things like that. So we will define these here in the view model. And we also have the repository, which is basically where we are storing, or not storing, but adding all our ArcGIS specific implementations. Now, for an MVVM architecture, like I say, it's just model, view model, and view. But you may be wondering why we are using a repository here, right? So the goal of using the repository here is to allow us to have all the data access in one place. So we don't want to kind of combine the view model or the data in the view model. If we do it, basically in the future, if we maybe just want to use another data access, that can be very hard. We have to kind of go and check the view model and do all this implementation. But when we keep all the data access implementation in one place, it just allows us to kind of have a great architecture. So in the future, it's very easy to know where to go and what to modify. So for the repo, I have the abstract class that is created. So first we have the group visibility stream. The second one is the layer visibility stream. And we also have like two functions like the set group visibility and the set layer visibility. Now, this is just the implementation, like the group layer repository itself is just the implementation of the abstract class that we define. So everything you see here is doing almost that. Now, our view is here, and the view is allowing us to render, the state and also dispatch the UI. So here we are doing we are using the ref, and this is coming from the report package itself, and it is basically allowing us to kind of interact with the dependencies that we have injected through dependency injection. Now, for those dependencies, I actually define them somewhere here. So you can see we have like the group layer provider, the group layers repository provider, and also the MVVM visibility view model providers. And these are the two, dependency injection that we did. Now, for a complex project, you might probably not want to define it, right below the view model. You can just have a specific file that actually, lists all your DIs or dependency injections that you are kind of doing. So, now, let me just talk a bit more about the ref. So in the ref, though, one second. Yeah, so here in the ref, I have the ref.watch and the ref.read. Now, we use the watch if, we want to observe like a state and, get notified or inform when it's changing, its value is changing. So we will use the ref.watch. This name doesn't matter. You can, however you want. And same for, so for the ref.read, what it does is it does allowing us to get the current value of the state. Right, so in our case, for example, I use the ref.watch to know when my state is ready, and I'm using basically the ref.read to get like the show settings function, because we don't want to we just want to get like or read like the show settings. We don't want to watch or observe whatever is changing there. So that's what we have here now. I'm going to run the project again. So right now, this is how it looks like. We have also the layer visibility bottom sheet, which is there. Now, I did one thing. So in the previous demo, you saw that I kind of defined almost everything, like the toggle, widget and everything. I defined them inside the same file, but I refactored the project, so we now have like a different widget that is kind of grouping all these elements, and I added it as a group layer visibility section. So it's doing almost the same thing we were doing there. So we have like the StreamBuilder, but if you notice here, I'm not using any set state. Because since we are adopting like an MVVM pattern, is that we have also a state management dependency where we're using Riverpod here. It just allows us to just build out like any specific widget we want, not that the whole or the full widget. So like Paul mentioned, if, for example, we used the set state here, we will be rebuilding again, the widget over and over again. But with this architecture, no set state is used, and we are getting the state every single time, so the UI can actually perform whatever action it wants, from the state. So that's it. Now, what I'm going to do is just showing, like, adding this widget directly to my bottom sheet widget. So we can now kind of handle also the visibility switch. So let's go over here, and it's simple. So we have the group visibility widget, group layer visibility widget. So having it this way will just allow us. So basically, we are having like the group layer visibility section here, and it's taking almost the the group layer that we have, and now we can start basically triggering, almost doing the same thing, but the architecture is just better and structured for any future feature addition or just testing the whole app itself. So basically that's it for this part, and yeah, I'll hand over to.
All right, thank you, Martino. For the second demo, here's some key takeaways. What we're hoping to emphasize today is we recommend adopting battle-tested architecture patterns. For example, the MVVM pattern clarifies how to divide responsibilities. The view handles rendering the UI. The view model converts user intents into actions, and the model interacts with ArcGIS sources or other services. Secondly, the dependency injection pattern promotes flexibility. It gives you a better way of managing your internal components. And third, popular packages like RiverPod provide a well-understood pattern to orchestrate state and manage your web of dependencies. And these patterns help you as you're building out your app by providing easier maintainability, better testing, and safer orderly growth. So that completes our presentation and demos. Are there any questions? Yes.
Can I find the code that you just showed on GitHub after the conference?
He's looking for the code. Do you have the code?
Yeah, okay. Yeah.
It's not posted currently, but Martino will post it.
Yeah.
Thank you.
Yep. Other questions? Yeah.
Are there any recommendations for how long like a Dart file should be, like how many lines? Or it doesn't.
The question was how many lines should a Dart file be? Yeah, and well, so you're not constrained at all. You're not forced into anything. I just follow more just a pragmatic approach to that. I generally just want to have one class per file, just so everything is where I think it's supposed to be. Yeah, it's just the longer it is, the more likely you are to confuse yourself and run into problems. So there's never really a bad time to use like the IDE tools to refactor. I don't know if you're like me, but sometimes I get lazy when I'm programming. It's easier to just dump everything into a single file. But it's really about a conversation between you and yourself 6 months from now. If you think that the 6 month future you is going to be confused by what you're doing, then you should simplify and factor out something. I don't know, does that make sense?
Yes. Like class is easiest.
Yeah, I just split by class, because then your file hierarchy matches your class hierarchy. And like sometimes I find myself looking for a class and I expect it to be a certain place. And if I haven't followed a consistent pattern, then I won't know where it is when I go looking for it. Other questions? I did have one other informational slide we can look at, and then I'll ask for questions one last time after this. So next steps. You can track us down at the Esri Tech Zone in the native SDKs section. We'll be around today and tomorrow.
Yep.
And then other sessions, there's the building app session that was this morning here. And then tomorrow evening is the Road Ahead session. You can learn about the new functionality coming to all native SDKs in the 300 series. And then here's our main URL to access our tutorials and reference and samples and toolkit. It's the developers.arcgis.com/Flutter. And then if you want to send us a message, talk to us, or talk to other developers who are using the Flutter Maps SDK, go to community.esri.com. And then the URL ends up being way too long, so you just click on developers, native maps SDKs, Flutter Maps questions, and you can post questions, and the team monitors those questions, and also other developers can interact with you there. And yeah, so any other last questions before we're done? All right. If not, we'll be here or in the tech zone. All right. Thank you.